Humanity could build a teleporter. There's just one catch nobody talks about. Right now, somewhere in a lab, physicists have already teleported something. Not a person, not yet. But something real disappeared in one place and reappeared in another. So the question isn't really, can we teleport a human? The question is, what exactly would arrive on the other side? In 2017, Chinese scientists sent something 1,400 kilometers into space, a satellite called Micius. And through it, they teleported the quantum state of a photon, not the photon itself, its exact state, down to the smallest detail physics allows. It worked. It's been done since, over and over, across longer and longer distances. So teleportation isn't science fiction anymore. It's a real, working piece of physics, which raises the obvious next question. If we can do it with a photon, why not with you? Here's where the real problem starts. A photon has one property to record, one piece of information. You are made of about 7 octillion atoms. That's a 7, followed by 27 zeros. To teleport you, you wouldn't just record your shape. You'd need the exact quantum state of every single one of those atoms, simultaneously, perfectly, without losing a single one. And here's where physics itself starts pushing back. In the 1920s, a German physicist named Werner Heisenberg discovered something strange. He called it the uncertainty principle. At the quantum level, you can't measure a particle's exact position and its exact momentum at the same time. Not because our instruments aren't good enough, because the universe itself doesn't allow both to exist as fixed values at once. So the very act of scanning your atoms perfectly runs into a wall built into reality. There's a second problem, and it's even stranger. It's called the no-cloning theorem, proven in 1982. It states something simple and brutal. You cannot create an identical copy of an unknown quantum state without destroying the original. It's not a technological limit, it's a mathematical law of the universe, which means, at the deepest level, copying and preserving can never both happen at once. This is actually why quantum teleportation works at all. It doesn't copy the particle. It transfers its state and destroys the original in the process. So if this scales up to a human being one day, the process wouldn't move you. It would end you here and build you there. Atom by atom. Instantly. From local material already waiting on the other side. Less like a transporter beam, more like an instant, perfect 3D printer reading a blueprint of you. And this is where the physics stops and something else begins. In 1984, philosopher Derek Parfit posed a question that still doesn't have a clean answer. Imagine the machine works perfectly. Every atom, every memory, every thought copied exactly on the other side. The person who arrives feels completely continuous. They remember walking into the machine, they're not lying, they're not confused. As far as they're concerned, they never stopped existing. But the original, the one who stepped into the machine here, is gone. So here's the question Parfit left behind. Is the person who arrives the same person who left? Or is it simply someone else, built from your blueprint, who sincerely believes they're you? Physics can't answer that. It was never physics' question to answer. So where does this actually leave humanity? Closer than you'd think and further than you'd hope at the same time. We already teleport quantum information, routinely, in labs around the world. Quantum computers use this exact principle to move data between processors. Quantum internet, an actual research field, is being built on it right now. So the engineering problem isn't impossible, it's just almost unimaginably large. Scaling from 1 particle to 7 octillion atoms isn't a small next step. It's the difference between lighting 1 candle and lighting every star in the observable universe. But unimaginably hard is not the same sentence as impossible. 100 years ago, sending a photograph across the ocean instantly would have sounded like magic too. So maybe one day, humanity solves the engineering. Maybe the walls, uncertainty, and no cloning get worked around in ways we can't picture yet. And on that day, someone will step into a machine, disappear completely, and reappear somewhere else, remembering the whole walk over. Confident, without a shred of doubt, that they never left. Whether that confidence is correct is a question no laboratory will ever settle. Humanity might build the machine long before it agrees on the answer. And maybe that's fine. Maybe identity was always this fragile a question. We just never had a machine forcing us to actually ask it.